So this is something like this CF6 is a lot small. So I got more. Is it running? Is it running?
Yeah, it's running.
Okay.
But I think leverage the video recorder is broken. That because it should be controlled by this controller.
Oh, it's not working.
Yeah.
Okay. But where do you see this is running? Like, if you go to home screen, return to meeting. This is the thing.
Oh, no. It just cause I scroll the meeting to there. This is
Okay.
a two screen.
Oh, this is extended.
Yeah, it is standard.
Okay.
And in the APAN60, the cheapest cost is lower than average. Yes.
The cost means the entry to you. You know,
No, it's a first thing.
so because your place is not around,
Yes.
does not have a cost. It relies on other round. They have. So if implements has level by OSPF in the cost that OSPF metric has, will be the cost. If the MPLS level can BGP, then the BGP's cost is the MPLS level. So MPLS is not a protocol itself. It is kind of a service. And it relies on the routing protocols metric to go somewhere. So MPLS is in short, MPLS does not have its own cost. It depends on which protocol is using to calculate it.
That's my. Thank you very much.
10:45 minute. 10:45 AM.
Yep.
So
About 7 minutes. Also start.
I wonder about this work for video. Space is yeah. You see that the number.
people
Yeah, because they're saying because they're it's their own similar, for the engineering methods.
yes.
We have office, they so this workshop is a kind of yeah. Not yet. I think they will, if you come to a big launch, you know, So we are all taking all these people, you can force them. Together. This one we go close to the gate work. Yeah, because everybody knows that we want to do that. And on top of it, the people have something. So it's almost. People in February. And the number is second of September. This one is. Similar also. Yes, similar program first always work out. This time we are doing workers and and then get the chance. That is
They want to do transition also, but it is start in the class. So then she don't know, we can have it.
Station phase. Thank you. Yeah. Okay, is the audio?
Yes.
So going to start the next part. And this part is more of the segment routing, the IPv6 data plane.
We can use.
Okay.
Oh.
So the programming or programmability part is to program how the source will decide how to go to the destination and which segment will be added to the segment list and things like that. And then we'll see some of the functions and the behaviors. So let's see some of the functions and the behaviors. The functions and the behaviors are basically encoded like the IPv6 address. So the router will know that, oh, this address means that actions are encoded in instructions which can be identified by the address. So this is the seed or segment ID format. Previously we saw that seed is like MPLS level. This time we are gonna see the seed as like a IPv6 address. So the format is, of course, the whole seed length is 128 bits, but it is divided into several pieces to identify some of the aspects, like it could be a device, it could be a link, it could be a task. So let's see how it does. So the first couple of bits are called locator, and it's a variable bit, so you don't have like a fixed number there. Then some bits are called function and some bits are called arguments. But altogether, this has to be 128 bit because it looks like IPv6 address. Segment routing data plane is IPv6 and the seed looks like address. So if you have less than 128 bits, so the remaining bits will be added like as 0. So it will be filled with 0 to make it 128 bits. Now the locators, these bits has two parts. So one is basically the block, the segment routing block, and the other part is called the node. So you can identify where to go or who is the my target destination to go inside the locator. And so this part usually is like a global block. Remember I told you that global block is known to the other segment routers in the domain. And the function and the argument, this can be local. So once you reach the destination, it knows what to do with that packet, okay? So in general, this can be, but there can be very specific cases, but because I don't have time, I'm not going to go very deep into like different cases. But this is like a generic concept of how this seed is formed. So you might see a seed, instead of MPLS level, you might see like this. And this might mean something to that node, and it will basically do the same thing as it does for MPLS data plane. Okay. So the function, the behavior, and the arguments. So function, I said like these values are the function. And what is the endpoint behavior? Once it comes to the endpoint, what type of actions it's going to take is the behavior. And the argument can be different types of options as well, associated with the function, this one. So this is basically an opaque, like an instruction. And why it's opaque? Because you will see why it's opaque, but it's like the local behavior that's related to the endpoint, and the seed will define what type of actions it's gonna take. Now there are two types of seeds. One is called routable, the other one is non-routable. Remember I said global seed means you want to tell people about this. And the non-routable is the local one. You don't need to tell everybody. It's the endpoint who needs to know about it. That's it. So there can be many different behaviors, and each behavior, you see some function is there, you see. So in short, because the list can be very long, and I don't need to go like with every single one, but in short, if you see end, it means an endpoint. And then if you see some kind of optional indicators there, it means it's some task or some function. So the endpoint, and this is the cross connect, for example. The endpoint, this is the table. So let's say if you want to instruct the endpoint to do a routing table lookup, so you basically telling n.t, something like this. If you want to check the cross connect at the endpoint, for example, a VPN cross connect or VRF cross connect, for example, L2 or L3 cross connects. So you can use this. So this can even be extended to V4 and V6. So this part, you see all of them related to 6 or 4, 6 or 4. These are actually tables. That means you were telling them that the endpoint that don't just look at my segments, but once you finish with segments, remove the header and look at the payload. There are more headers, and finally match it with your routing table and then decide which interface to go. So it's like decapsulation and then routing lookup. Remember, we are talking about this PHP. So the label will be removed, and then finally, if I want to send it to CE, I have to send it as a normal packet, not really a MPLS packet, because the other side does not understand MPLS. So the same thing. So this is D is the decapsulation, and then you can have either cross connect or table and things like that. So it's like the name and related function. Each function has some meaning to the endpoint. Flavors. The function needs a flavor to mention, otherwise the router will not behave as you are expecting. So there are 3 different flavors. In MPLS, we had one flavor only. We had the PHP or penultimate hop popping. But here we have, actually in MPLS, we also had ultimate hop popping, but we don't say that. It's like not needed to say. But here there are 3 different flavors, and we need to know each of their definitions so you understand how it works. First one is already we know, PHP or penultimate hop popping. Here it's called PSP, penultimate segment pop or popping. And the next one is ultimate segment pop. So penultimate segment pop or PSP is I want the second last node to remove the top segment. And this one is I want the last node to remove that, not the previous node. And the next one is I want the last node not just to remove the segments or segment routing header, but also check the destination information in the payload and then look at the routing table and then take a decision. So this is like decapsulation. And the decapsulation means you also want the routing table lookup as well. So this is like USD. It's not US dollars. Yeah, so the choice of the flavors is decided by the source. So in segment routing, you'll see everything is decided by the source. And that's similar to source routing, but actually not source routing. So what is PHP? I already explained. So how it works is the last router of the whole segment, the last router will not do the hopping. It's the previous router or the penultimate router will do that. And for this case, this is an example. It's similar to MPLS that we had. So we had this diagram before, right? Before the break, we had similar thing. So this one. So R1 has an instruction. Here is the instruction, and instructions are basically policies, and then each of the instructions are called segments. So I have now two segments. One is R1 to R3. I have to go till R3, and the second segment is R3 to R5. So the first segment is the active segment at the moment. So the destination is R3, not R5. So the packet goes, normally normally the IPv6 packet transfer happens based on normal routing table by R2. It comes to R3. R3 looks at the header. It finds that I'm the last destination. But if I look at the list, I have one more task remaining. So I'm not the ultimate destination. So I have to now copy the next one here, make the new packet as a segment endpoint. I would like to make the next packet. In our previous example, this header remained. This one became here like a IPv6 header, but you see penultimate hop popped the segment routing header because it's the last router in the segment. Now by last router, this should be the last router, but by last router I mean who is dealing with the header is the last router. You see, this one does not deal with the header. Header means not segment routing header. It deals with the IPv6 header, not the for this router. This packet is just an IPv6 packet, not a segment routing packet. For this router, it's a segment routing one. For this router, again, it's just a normal IPv6 packet. So header is here or not does not make any difference to R4. So the last router means in the list. What is the last router in the list? So this one is R5. The previous router is actually R3 in the list. So that is the penultimate segment popping. Okay. So this is useful in some cases to speed up, because this router does not even need to know whether because this is actually no meaning to R5, because it's not going to even look at it, because this last router and segment left will be 0. Basically, the only job it will do is remove it. Why it needs to do that? It can be done by this guy, because this guy already processing it. So it's not a new process for him, but for him, it's going to be an additional process. Why we do that? So just simply remove it. Now, sometimes this can be problematic when I have to identify which VRF I have to send. Then if somebody removes the header, how can I find out which VRF I'm going to talk about, right? You understood, right? Or if I am the destination, I have to process something. Then I also need to know the headers, because I have to first decide, okay, I am the destination, so let me decide what I'm going to do. So this is okay when it's simple IP connectivity with a neighbor. This is okay. But this is not okay when it's a VRF, or I have to find out which service I want to serve. It's a VPN, and very difficult if somebody remove it. So this is not suitable for all the different tasks. And this time we are not talking about MPLS level that you remove one level, but the next level still exists. It's not that MPLS level stack. The stack happens in the header itself, not like there are more headers. I'm just removing one header, not like that. The list is not an independent header. The list is just part of a header. So if I remove the whole header, very difficult for the endpoint to find out where is which VRF it belongs to. So in that case, PHP may not be a good choice. And in the lab, we'll see that it does not work if I remove the hop in the penultimate router. Now the other options is ultimate segment popping. It's important because like I said, VRF detection, you might need the USP. So in that case, the penultimate will not remove it. It will come to the last router of the segment, a very ultimate last router. It will remove the header. And of course, by that time, it will understand which VRF it should pass to. So that's called ultimate segment pop. And this is the decapsulation if it needs to look at the routing table as well, not just the VRF. In VRF, you don't look at the routing table. If you know who is the VRF, you just pass the packet to the VRF. But if you want to look at, because if you might have multiple customers in one VRF, if you want to look where to go, you can do that. But originally, actually, you don't want that. You want one customer in one VRF, usually like that. But that's what the cross-connect concept came, right? It can have multiple, it's like a LAN, it can have multiple customers or multiple CE in one VRF. So because telco infrastructure is quite different than the normal, internet infrastructure, normal like enterprise infrastructure. Telco can have so many different requests because customers of the backbone operators are banks, academic like universities, the enterprises and the data centers. They might have different types of, so it's not just one different one. Okay, now to carry the information. Remember I said LDP is a problem for MPLS because it's an additional, not a problem, but it's an additional process. RSVP-TE is a real problem. It's the only option we had for MPLS to do traffic engineering, and that protocol is horribly, inefficient protocol. So to solve the problems, if segment routing can use existing routing protocols that I have to mandatorily run, for example, you cannot escape from OSPF or ISIS. You have to run an IGP. You cannot say, I have a very small network and I want to do IGP. I don't want to do IGP. I want to run a static. It's possible, but it's such a bad idea to do static routing in a network, even though it's very small. And if you are so small, SRv6 is not for you, of course. So don't bother about those things. So if I want to run a backbone transmission network, if I'm a telco or I'm a provider for the backbone services, I have a very big network, of course. That's like already there. And if I can use existing IGP, I don't need to run new protocol. That's a good thing for me because my router's process will be saved. So the existing routing protocols we have is OSPF, ISIS. These are for the IGP, and BGP is the only candidate in our external routing. So if I can utilize these two types of routing protocols for both of my requirements, like best path and also the traffic engineering, that would be a best way. That would be a very good way to solve the problems. And that's where this SRv6 came with a beautiful idea of using extension of IGP. And when I'm talking about extension, you can only extend a protocol's capability using something called TLV, type, length, and value. TLV is a number in a header that indicates a function. So if you can, for example, next header 43 means routing header. That means it can have its own infrastructure or own format, and that can mean a new thing for the routers. So this type of indicators, it's a numbers, can extend the functionality of a protocol. For example, IPv6 can have so many different other functionality in future because there is a field called next header. A new number is a new functionality. So every single new number is a new functionality. TLV is again the same thing. OSPF version 2, lack of the TLV field. Many of its field is hard-coded with 32-bit. That means it cannot work with IPv6. And that's why we need a new protocol called OSPF v3. It's not OSPF version 3. It's a new protocol called OSPF version 3. We may think like it's probably an extension of OSPF. Actually not, it's a new protocol. But this time, network engineers understood the deficiency of version 2. So they have now the capability of TLB. ISIS already had it, BGP already had it. And that's why you see BGP is such a successful routing protocol in the world. It is lasting in the world for more than 30 years without even a candidate. Nobody can compete with BGP, but BGP has seen so many changes in the internet, but BGP didn't change. VRF, MPLS, VPN level, whatever you did, BGP is still BGP. Why? Because it can have the functionality added, and that's why it's called multi-protocol BGP, and it's done by the TLBs. The new functionality is done just by the TLB. It's the address family and sub-address family, SAFI and AFI coding, which extends its address family functionalities. So in SRv6, we are using IGP as the extension. So in that case, we have two choices to distribute the level. Here we are not talking about level, but talking about the seed. So how advertise my seed in my network if I want to use IGP, because my seeds are IPv6 addresses, I need IGP that understand IPv6. So I have only two choices, ISIS and OSPF v3, right? And now v3 is not really that widely deployed for SRv6 by the vendors. So if you have one vendor's equipment across your full SR domain, and that vendor supports OSPF v3, you go with that. But if you want like a multi-vendor solution, multi-vendor platform, you have in your network and you want it, I think ISIS can be a good choice for you, because ISIS is supported by most of the major vendors. So there are some extensions, and by extensions, I mean new TLVs. Why I need new TLVs? I need to carry new information, segment IDs. I need to carry segment IDs in a OSPF or ISIS packets. I need to carry those information. That is what I need. And then I can remove LDP from the picture. I don't need LDP anymore. LDP is just doing one job, distributing the levels. If OSPF can do, or ISIS can does the job, do the job, then why I need the LDP? So that's the idea. So this segment routing extension, and I already covered the part, and I said that ISIS and OSPF v3 is our only choice here, and these are the TLVs that can carry different things. So first one is the locator. Locator, remember I said, is a global prefix. When you by global, I don't say public prefix. Global means in my SR domain, it's a unique prefix assigned to individual nodes. So this is, I have to tell my neighbors that, I have this prefix, like a routing protocol. I need to say, I have these IPs or prefixes. Same thing, I'll say in SR that these are my SR prefix or SR domain, SR locators. And then SR capabilities is actually the sub TLVs, where you can do what other functionalities needed. Some of them can be the end seed, n.x seed, n.d seed, sorry, t seed. Remember, there are some different types of capabilities I need or functionalities I need. For the BGP services, I have the control plane done by BGP and data plane done by SRv6. The BGP can carry my customer VPN or L3 VPN or L2 VPNs, okay? And we'll see the picture to see what it's mean. So for L3 SRv6 services, we had a different TLV, and L2 v6 services, we have different TLVs. And these are actually identified by the seeds for the prefixes, and BGP will carry in its multi-protocol BGP address families. So BGP can do L2 VPN in a different address family, L3 VPN in a different address family, so it can do the same thing for SRv6. So multi-protocol BGP will carry those information. So this is like a similar example that we had previously for MPLS. This time I'm gonna do this for the SRv6. So PE2 has a BGP multi-protocol BGP configuration with PE1. Previously, it was saying, hey, I am using level 1, 2, 3, 4. But this time it's saying, you know, I have a service seed. Why I'm saying service seed? Because it's a VPN. VPN is a service. That's why it's saying service seed. And you see this is an IPv6 prefix instead of a level. Now, this guy needs to just know what is the prefix of this node. It does not really need to know all the other these numbers. It knows the numbers, but it can use this prefix to come to the node, and node knows that this is a local seed and I can utilize it. So in between, none of this router needs to know about this. None of the router needs to know that this is an SRv6 packet. And that is the benefit. In MPLS, everybody needs to know that. Everybody needs somebody in the middle. If they don't understand MPLS, it's not going to work. But here, rest of the routers is just doing a IPv6 packet routing. No, even not reading the header. The SR header or segment routing header is the next header, not the main header. So they are reading the main header, not the next header. And now, so there could be two types, and you were asked this question whether it can, what sort of path it's going to take. So first one is by default, it's going to take the shortest path first or best effort. And then we also have the SLA based, which is the traffic engineering. And instead of RSVP-TE, we have a nice way of instructions, you know, go via this node, and then use this link. So instead of the RSVP-TE, we can do that. So by both of these solutions, we basically eliminating LDP and RSVP-TE from the picture that we had in MPLS. Now let's see. This is a real example, and after that we'll do the lab. So this is more of the real example. So let's say this is the prefix. In my company, this is the prefix. I want to implement my SR seeds with this prefix. So this is mainly my global block, like main block. Now, why I have an IPv6 prefix? Because I have to do it, because in all the SRv6 list, I'll always use an address. This address will indicate my routers, will indicate my link, my VPN services, everything will be an address. So all my routers will have all their seeds from this subnet. So this is my IP plan. The way we'll do now the segment routing plan, okay? Now, each of my router, I'll assign them a /48 out of this /32. Now, this is not standard, like always like go like this, not like that. In our lab, you will see that we are doing differently, okay? In our lab, we are doing differently. But what I'm saying is, this is my prefix that identifies, let's say, my first router, 1. If I have 2, it's second router. So for example, my router number, let's say 100 number router is 64. 64 is 100 if you convert it to the hexadecimal. So looking at this address, you understand that I need to go to this router, 64. That router I need to go, something like this. So here, this is assigned to a router. This router can further use other bits to indicate different services, different links, different VRF, okay? So this plan, variable, it's not 100% has to be like this. It's a variable. So if you use the locator address smaller, you get more bits for functionality. Or if you use because here there are two things. One is the block and the node. So if you use a block size smaller, you get more nodes to cover. If you have block size bigger, you get less bits to cover the nodes. If you are a very big operator, maybe you just use 16-bit for locator and 16-bit for the router number. Yeah. And the flex algorithm, there is not really very big development in terms of the flex algorithms. So not really very big numbers over there. So you can just keep it like normal, like 0. 0 is also. Now this is a more realistic plan. What we are doing here. Let's say my locator is 64 bits, but I'm not suggesting you go with the 64-bit locators. Make it even shorter. It's also okay. Like functions are 16-bit and they don't have to be exactly 128-bit. Like I said, if you keep less than 128 bits, there will be 0 at the last couple of bits that you missed or that you didn't use. That will be all 0. Now these are the functions. So locators will be followed by functions. So let's say I reserved 16-bit for functions. Actually, this is actually reserved for functions. You don't change it. So let's say 16 bits, and this is like an end function. So this one means that's the router. No function actually. And then if you want to do a PSP, so if you indicate that the previous router, you have to remove the header, you can indicate with this one. So these are basically all, if every single number is a signal to a task done by the source at the source. Okay. Now this is for the USD. This is for the towards neighbor, second neighbor. This is do the decapsulation and look at IPv4 table. Okay. And if you put now together, it will look like this. This is your node number 3. So node number 3, this 64-bit indicates node number 3 because probably you have mentioned 3 there. That's why it's node number 3. You can do this numbering when you configure. Okay, this is coming from a plan, not automatically by the router. You have to configure these numbers in your router. So let's say this is my node number 3, and this is just 3:1 is node itself. So if I want to reach the node, I'll use 3:1. But if I want to do some more thing like identify a VRF, identify a VPN circuit and things like that, I can do different things. And if I want to do like decapsulation and then IPv4 lookup because it's an IPv4 packet, I can do that. If I want to do IPv6 lookup, I can do v6 for IPv6 lookup.
So who define the function number?
You will configure it to define the functions. So when you configure SR, you have to configure these things, and some of the numbers you don't need to configure. For example, at the end function, you don't need to configure, like the level. You can configure the level or you don't configure the level. The level can be assigned automatically. But whatever level is assigned, it is in the table of the router. The router knows that this level has been assigned for this task.
But the meaning of the function like n log x is universally defined by some.
You will configure it. No, it's not universally, but you will configure it.
Oh.
So these things, and in the lab, I think it will be more clear that you have to configure it. Otherwise, it's not gonna work.
So I can choose whatever I like.
Yes, and the recommended practice, I think, is instead of using public IP, it's better to use the unique local address, which is like a private IPv6 address. So you don't expect any packet coming from outside your SR domain. Yeah, so nobody knows that something is going on inside here. But if you configure with public IP prefix, then you have to configure the security like the SCL kind of thing as well. So it's better not to go that way. So it's easy with the unique local address, but you have to configure it. So let's see some of the services, how we are going to do in this example. Let's say my loopback address will be something like this to indicate that it's router 1 and things like that. So here is with this formatting, we have done this SR domain. So you understand this is the SR domain, and these are my edge routers of the SR domain. And if you look at each of the routers locator information, out of the /48, each of them has a /64 locator. Locator means is the node itself. Now, in our lab, we have 48, and which I recommend you use 48, not like 64. But 64 is also okay. 64 is also okay. Again, this prefix is variable. This size is variable. So, so here, 64. If you look at this number, everybody has a different number. And remember, locator is global. By that I mean within your SR domain, everybody's number is unique and they know each other's number. Okay, how they know that?
Controller.
You know, how this locator information will be known to the other routers? IGP, yes. Actually, I have a gift for you. I forgot to ask question before. Yeah, because remember IGP extension capability. Okay, so this is a small screwdriver from. Oh, sorry. Yeah. So you see when they advertise the IGP prefixes, they will also advertise the locator information, because locator is important to know. I don't really need all the time. I do not need to know their services because that can be local. Those information I don't need to probably know, but I need to know how to reach to that node. And if I can reach, then that node itself can check its own planning and then can identify which service it's going to use. But for locator, it has to be spread all over the place. Oh. So it says here that the locator information is shared by IGP. If you see the loopback, you can tell that this prefix is not the same. So it can be from the same subnet, can be, but better to separate loopback from the SR domain, SR prefix, because loopback not necessarily you have to run SR. If you want to run IGP, BGP, IBGP, loopback is an important address you should have, right? So, so this is the scenario we have, and now in the middle, all of them are the domain routers, but the two sides are the edge router because the customers are connected. Now let's look at some of the scenarios. Let's say my service is a VPN, IPv4 VPN service, but the underlying routing is the shortest path. So I'm not doing traffic engineering, just shortest path. Now, how can I connect? So let's say this is VRF10. So between PE1 and PE2, I have two customers and they want a VRF or VPN connectivity. And so how I'm gonna, so, and you see the locator and loopback information like the before. So what we are gonna do is we are gonna choose, for example, this is the best path because this path's metric is a little bit higher. So IGP decides that, okay, I'll go and take the upper path, okay? Now, if I see how it's gonna do, so this guy's service VRF, a service seed or service segment ID is up to this point. You see the locator information was 200 db 0.14. It's okay, but then this value indicates the VRF10 in the v4 routing table. Okay, in the v4 routing table, and so it's passing this. It's definitely shared this with PE1 to multi-protocol BGP, right? Remember, the VPN level is going to be with multi-protocol BGP, and the locator information will be exchanged with the IGP. Like the neighbors, like adjacent information will be with IGP. And when you have a targeted like service between two, it's also same for MPLS. In MPLS, if you want to do VRF, VPN, V4 traffic, like routes, you do like BGP configuration between these two nodes because they don't need to know. It's a service between two routers, but they need to know the locator informations. Okay, so now you say this to them. What it's gonna do is it is going to create, even though it's an IPv4 packet, and the backbone is V6 only, so no V4 there. And that is also a benefit of SRv6, that it's a future ready network. So in future, we are expecting there will be no IPv4, so you can still, think it as an advantage of SRv6. So let's say how it's gonna build this. So I'm gonna go from CE1 to CE2 with this destination is this one. So this is the normal packet, IPv4 header. It's not going for the SRv6 header. So this like a normal packet came, and it has the destination of this, but there is no existence of IPv4 here. It only understood by the CE and its v4 table. This up to this point, it
it will understand only if it decapsulate and read the payload header, and otherwise it will not understand. Okay, so this IPv4 packet will come to PE1, and PE1 will take a look at it. It will add its own address as source address. It will add the destination address, this one, and then it will put the payload inside the IPv6 payload, and then we'll try to pass it. So how it's gonna do it to look like this. You see this this sent actually originally a before packet which goes in the payload. And then the new header created by this one is its own IP, loopback IP as the source, and destination is this one. And the rest of the routers is basically normally route with the best path or shortest path to this destination. And this destination means how it knows. They don't know this information. They will just look at the the locator information. The locator information will take them to the final destination. Okay. So yeah, the normal IPv6. I'm just gonna quickly jump to this one, and then when it comes here, because it has the DT4, you see this D4, like a decapsulate and look at IPv4 table and try to find your VRF number 10, something like this. This has a local meaning to that router. So it will basically try to decapsulate and try to look at the IPv4 routing table, and then finally send the packet as a normal IPv4 packet to the CE2. Now this is next one is a traffic engineer. So this is the shortest path. This time we will steer. So here, interesting thing is you don't have a segment routing header. You see, because you didn't need to. You didn't need to tell, go there and then there, then there. You don't have any segment list there. You said, go how you can go, but my destination is there. It's like a normal IPv6. And then here, this time we'll do engineering. And we say that, go to the destination P2, but you have to go to R5 and then R3 and then there. So I'm basically saying like this. You go from there to R5, and I don't know how you go to R5. In between, you can take any path, but you have to go to R5 first and then to R3, and you can go R3 by many different ways, but I don't care. But you go to R3 then, and then finally reach there. Now I have to have a segment routing header, and rest of the stuffs are same. The rest of the descriptions are same. I'm not going to talk that detail. So here, P1 has been instructed that your segment list should contain the locator R5, the locator R3, and then the destination service. And you can see they don't have any service here, because in between you just only want to identify the node, not the service, because they are not your final destination. So why you look for service? So here the list is going to be the header will look like something like this. Yeah, here. Source is my IP, my loopback usually. Destination is my first of the list, and that's just copied here. So this is my destination, not the ultimate destination. And segment left is 2 because I'm dealing with the active segment, which is the first segment. So I have 2 more left. And this is similar to what we see before the break. So now this packet will come here, but for this router, it's a normal IPv6 packet. Okay, so normal IPv6 packet pass through the transit, come here to R5. R5 looks at it. It finds that, oh, I'm the destination. Look at the segment list, or 2 more segment left. Okay, I'll ignore because that was the active one. I have to swap it with the next one. So it just copied it here. So it's basically 3. It looks at the table, IPv6 table, and finds, okay, 3 is exiting interface here, and it will just go there. And then it has been reduced by 1. So previously it has been 2. Now 1 more segment left. It goes there. This is again a endpoint. And endpoint means it will look at the list. It say 1 more left, so make it 0 and take the last one and copy it here. So it will finally come to the P2, and P2 knows that, okay, I'm the last one, so I better look at my service values and understand what I have to do. It understands that you have to decapsulate, means remove all the headers. It look at the routing table of V4 routing table. It finds that, okay, I know destination goes through this VRF. Okay, let's take this path. Okay, things like that. So it's basically programming, like encoding the meaning within a number, and then tell people that, you know, you don't need to know the number. I know the number. You just give those things and bring it to me. I'll check my register and I'll find out how to do that. Now this one is we'll do traffic engineering and for IPv4 whatever we have seen, but this time we'll do a PSP or penultimate segment popping, because in previous example R3 could have easily removed the segment because that was the last segment. R5 PE2 basically only had to do decapsulation and look at the routing table. No need to check the header because it doesn't, you know, have any action there. So what you could think it like this. For example, same thing. I'm gonna quickly go. So this time the path is, let's say, this way I want to go, and the segment list. Just think about the segment list is this, and this time look at this one. In previous example, we had 5 and then 3, right? Now this time I'm saying go to R1 and then R5, but do penultimate segment popping here. Look at the number. DB801. So that's router 1. 05 is router 5, but I don't have 05. I have 05:11. That means something to R5. That doesn't mean anything to others, but it means something to R5. And this 11 is called PHP flavored seed, or route. R5 will understand I have been instructed to remove the header because I'm the last penultimate header, so I'll remove the header. But if I didn't have this, it would do a normal, like we call it ultimate segment hopping, or USP. The previous example was USP, and this one is PSP, and identified by a IPv6 address. And that is how, you know, you trigger different types of actions. So in this case, the IPv4 payload comes to R1 like this. R1 change it to the next segment, and when it comes to R5, and R5 removes the header, and it makes just the IPv6 header, keeps like that, and then go. Okay. Now, next example, actually lab. I think I could have added more slides. You know, this is like a 5-day workshop for us. We do 5-day hands-on workshop on segment routing. Then we start from the very beginning of MPLS and how LDP works and why MPLS has some issues that has been addressed in SRv6, things like that. But because it's a very, you know, even though I couldn't even finish in like 1.5 hours, I had to extend it. But let's see the lab. And I'm not so sure if you can follow me in the lab, but feel free to launch the lab. But I will do a demo quickly, but I may not be able to troubleshoot if you face any problem. But I think you will not face any problem. So remember, in the beginning of today's session, I showed you that in our academy there is a page for today's tutorial, and here is the lab. I'm gonna follow Juniper lab, but there is a Cisco lab as well we have built. But if you click on this lab, you need to log in. That's one requirement, because we don't track individual personal data or something, but it's a very short task to create an account. There are only 4 questions. It's not related to our academy, but for any APNIC service you want to use. It's called My APNIC account. And at the moment, if you don't like, no need to create the account, you can do it later. It's not even your not even your real email address you need. You can just, random email, whatever you like, you can just do that. So it's like privacy wise, it's no problem. So let me log into my account so I can show you the lab. This is a Juniper lab. So we have Juniper images here, and all images are like registered images. So no like free or pirated images here. So Juniper licenses we have because we have those purchased, and Cisco we have also purchased. And if any vendor gives us like a complimentary licenses, we also build lab here in our lab. But you see that we have so many different labs here, so you can actually practice any of the lab. There are different types of lab, but I'm gonna show this one, and let me delete because I probably saved one of the versions again. Okay, of course you don't see monitor because you are not an admin of this one. You only see instructions and launch lab. So I'm gonna launch this. One more thing I wanted to show, let me know, and if we have 3 data centers, so you click here and you can select the data center. We have different, but by default, because from here probably Singapore is the closest. Even if I don't select it, Singapore is gonna be chosen. So launch lab, yes, and then it will pop a new window. If you have a pop-up blocker, you have to allow it. You will get a warning that your pop-up is blocked because this is a new pop-up window. So accept that, and then I think whatever theory we have covered, it will be very good to see in real practice. Then the whole session will be very good to understand. So let's do the lab. This lab will be launched with all the routers in there, and I'll explain a little bit of the lab setup, and then we'll go for configuring each of the routers. We have some P routers and PE routers. We have L3 VPN. We have host-to-host traffic as well. We have traffic engineering tasks. So all are combined in the lab. So it's a very nice lab setup. Yesterday I did an automation lab. It's also done here. So why it's taking so long? Because it's a Juniper OS are a little bit heavy, and it takes some time to boot up. And these are real, not real, but virtual images, but still with almost all the functionalities you have for your real page. But it's a VMX. It's an MX series routers virtual image. And once launched, you'll see this screen. Let me make it a little bit bigger. And on the right side, you see all the instructions. If it is too short, too small, there is something here which can make this screen. Behind this screen, there is like a zoom in out, which you can do. Now, these are the tasks we'll do. There are first one is the link IP address, then IGP ISIS config, then SRv6 config, then end customer config, then layer 3 VPN, then traffic engineering. So these are the tasks. First 2 tasks, even if you don't have SR, you need to do that. If you build a network, you have to configure IP addresses and configure IGP. So let's see that topology here. Let's make it a little bit bigger. So you see, we mainly have this SR domain. The SR domain is AS64512. This is the transmission or transport network provider. So we are the provider, and we have two customers, VPN sites. One is AS65000 and 65001. Let's say it's the same customer, and they want a L3 VPN to connect all the way to the other side. So basically, this server 1 and server 2 needs to communicate through the SR domain. And then we have also host 1, 2, 3, 4. They are directly connected. They are not a CE routers. This is a CE router, so it's a VRF. And this is like a normal, cross connect or normal directly connected LAN. Okay. If my host is SR aware, host can generate SR packet. Okay. If, for example, this is not SR aware, so it will not generate SR enabled packet. So this is my PE. But if the host is SR enabled, many operating systems, they understand SR now. So the host can itself generate SR header. So it's like not really only the routers is gonna do it. It can be done by the host. But anyway, so in this is a quick intro of our topology, and we'll use this topology for the rest of the labs. So let's go next, because there are many other information, like we have provider-edge routers, provider routers, all of this I already covered. So what is PE, what is CE? It's like that. Don't worry about it. Now, there are some comments, some additional information. You just feel free to read them. Anything else? Next, let's go next, and we'll see more and more instructions coming. Okay, so this one is the first one. Go next. This is the first task, is the IP configuration. And this is again a very busy diagram, and you can see if you make it bigger, it's basically what IP you configure this side, what IP you configure that side, what is the loopback IP you configure to build the network, like the IP configuration to make the neighbor relationship and rest of the stuff. I need to configure IP. Each of the interfaces, I have to configure the IP addresses. Now it's very time-consuming task, but we'll do it faster. We have in our lab, you can do it faster. So how you do it? I'll go to PER1. So you see PER1 is this one. PER2 is this one. PER5, PER6, and this one is PER3, PER4, because they are providers in the middle somewhere. And this is CE, and this is CER2, but their name is R101, R201, something like that. But when you see this is a hyperlinked node, if you click, this screen will become the console of the node. Or you can go here, click, and you can see that any router you or any node you select, the console will be that one. So first, let's say click here, PER1. So I'm now in PER1, and this is the router console. I have to log in. So login information, you see the T icon. T icon is the text to copy from here and paste on that side. That way I'll save the time to do the lab. Okay. So click, it becomes 8 unique, enter. The password is training, click, and then enter. So I'm now there, and then to go to the config mode, I'll do configure. And then I'll first change the host name, PER1. I'll go to the interface to edit and give the IP addresses. So you see here is the setup configuration we already did for the gigabit interfaces. We have loopback with IPv4 and IPv6. We have 001 with IPv6, because I told that we'll have a v6 only backbone. So in the backbone, we don't have any IPv6 address. But why I have an IPv4 loopback, we will do some test. Okay, so and this three is 1 to R2, R3, and R4. In our topology, you see R1 is connected to R1 is connected to R2, R4, and R3. You see the links are connected. So I will configure 1, 2, 3 interface, and then I have a customer interface as well. And then I have a loopback as well. So all of them are here, properly done with the address plan. Okay. So instead of writing everything, I'll just click on the T, and then it will do all the config here and enter. And then because I did the config, I need to commit, and I do commit. So this is P1's interface config done. PER1. Now let's do the similar thing for PE2. So just click on PE2. Please also read the descriptions and information, because there's many of the places you will see that some instructions explains why you are doing it, what are the further instructions or further information, things like that. So now I'm on the R2, and this time interface configs again related to R2 will be here. So I'll just click on T. It's added and commit. Do we have time actually? Yeah, we have half an hour. Yeah, I should be able to finish it. So R3 again login. If you cannot follow because I'm going so fast, don't worry. This lab you can actually do it later, but and also you see every single stage has a description why we are doing it. So yeah, you can do it by yourself later, don't worry. So training is the password. Now I'll do the config of IP addresses again on this router. And then for P4, enter first, because the logging prompt sometimes don't show up. It's fine. Training is the password. Configure R4. R3 and R4 does not have any customers, so you see that's only the interfaces, okay? No customers. But R5, remember R1 and R5 has a different kind of thing. R1 and R5 has a CE as well. So one more additional interface for R1 and R5. And then there is a customer, like a direct customer. So these two additional things go. So this time R5 here, this is R5. Click the username, click on the password, and configure the interfaces. You see the R5, that means you will see some PEC link as well, okay? Because it is R5 and it has a CE. The CE is put there intentionally to do the L3 VPN. Okay, now that's the last router. Of course, we have the customer routers as well, but there's the last SR router. Username, password, and then configure. Okay, now the customer routers. Customer routers only has a link to PE and a link to their servers. So two interfaces, easy configuration. So this customer router, these are also Juniper routers, so similar configuration. If you are not familiar with Juniper config, there are some explanation of how you configure it, but better to be familiar with the syntax of Juniper. Juniper has a little bit different syntax than, actually completely different types of syntax than Cisco, so better to see how it works. This is my second customer router, and hopefully after that the IP configs are done. So this one, now verify point-to-point interface configs, okay? What you can do is you can just see show interface stars, show we didn't configure the ISIC yet, but you can just see show interface stars. For example, if I'm in this router, what I can do is show interface you see the IP information and the line protocol and the physical interface is up or not. We can do the match as well. So you see this command, show interface stars, and then match your interfaces and loop back interfaces and the INET6 together. Then what you can do is you can find a nice output, something like this. It's like grep or match it. Okay, matching means you don't need to see everything, you just see whatever you configured in. So these are the matching configuration we have done. I'm not going to check all the individual P routers and do this checking, but if you go to P1 here, you can actually do ping to the neighbors and their IP addresses, things like that. For example, here I'm pinging R2. Let's say this is the R2's point-to-point IP. So don't think that this is 1 means R1. These are point-to-point IPs not yet started, like segment routing prefix is not yet started. This is like point-to-point IP. So I'm gonna ping, yes, it's working. So this way you can do every single interface of every single router and see whether the ping works. But I'm thinking that our configuration is okay, no error came, so I'm thinking that all of them are working. So let's go to the next stage. This one is ISIS, and ISIS is not in any other AS within our AS, which is you see the SR domain. So within this network, we need to configure ISIS. And remember, the normal ISIS, the regular ISIS, you just configure simply. But for SR aware ISIS, we have to do some additional configuration. Remember, the SR extension, the IGP extension means the capability extension needs to be configured additionally. And probably when you buy the router, you also need to tell them that I need SR. That means it may cost some additional licenses and things like that. So make sure that you talk to them vendor before you decide which device to purchase. So now first, there are more and more information. I'm going to cover it, but I'm going to cover by whatever I feel like needed now. But please read them. Each of them are nicely explain what are we going to do and why are we going to do that. In ISIS, it is recommended to use level 2 because that's the backbone area in ISIS concept, even though it's not similar to OSPF, but yeah, very close. This is the net ID we are going to use for our ISIS. For router, for example, for router 1, we probably use 4940 and then the loopback interface converted to the ISIS. So detail is here. I'm not going to cover ISIS because it's a different conversation if I want to go how ISIS works. I don't want to go and do that. But the main idea is we have 6 routers in our SR domain and we need to enable ISIS there. So let's do, because I already did the login, let's do the configure. Then do the, so this is like router ID. Any routing protocol needs a router ID. And usually we do router ID with loopback address of my IPv4 because router ID is a number of 32 bits. It's not an IP. It's a number of 32 bits. And people do practice with their IPv4 loopback address to become the router ID. It's not mandatory. You can select any. But very important thing is that router ID cannot be same for both for 2 routers. So it's better to use loopback as your. It's kind of a practice in the industry. So here, this is my loopback. Remember I said why I'm configuring IPv4 because of that's the loopback we'll use actually for the router ID. Router ID is not an address. I mean, not an IPv4 address. It looks like an IPv4 address, but it's not an IPv4 address. Now, interface, I have to enable my interfaces with ISIS in Juniper. First, you configure the net ID, and net ID is called ISO because ISIS originally developed by ISO, and Juniper call it ISO address. So this is like the net ID. You can call it router ID in that sense in ISIS, but that's just called a net ID or network entity title ID, NET, network entity title. Okay, anyway, in ISIS, I want to enable my physical interfaces. So all the physical interfaces needs to find out their ISIS neighbors. In R1, I have 3 interfaces going to the neighbors. and then I will go to protocol ISIS. I'll disable level 1 metric because level 1 metric is called I'm not running level 1, so I'm disabling level 1. I'm enabling level 2 wide metrics because wide metrics has more bits to cover, like bigger number of metrics value. These are like common ISIS configuration, nothing related to SR, but common. Now this is IPv6 unicast topology because ISIS has the capability to run multi-protocols. So ISIS IPv6 unicast command will enable IPv6. Now by default, all the metrics are 10. By default, this actually we are gonna make this explicitly configured 10. And then level 2, each of the interfaces will run as level 2 ISIS. And then also it will be a point-to-point configuration, so it does not do the election for the DIS. You know, OSPF has the DRBDR, designated router. Or ISIS also has similar concept called DIS, designated IS. Okay. So let's do the configuration, and please don't feel these are related to SR. This is not related to SR. If you even do a normal network configuration with ISIS, these are the basic config you have to do. Interesting is the loopback interface here. Loopback interface is passive because I don't have a neighbor on the other side. I don't need to send any hello or kind of thing. Actually, modern ways, they don't send hello on loopback interface. So even if you don't do passive, it's also. Anyway, so this is done, and let's save and commit and quit. So this is first router. I'm going to the second router. All the 6 routers needs to do this config because they need the adjacency. So this is router 2. Just clicking on that to do similar config. Whatever I did, just I did individually for router 1. I'm also doing router 2. And then router 3, just to save time, I'll just copy without explaining because I already done the explanation for R1. It's the same thing. Yeah. So configure. And then going for R4. Configure. Going for R5. Configure. Going for R6. Yeah, so that's basic ISIS configuration. Means I should now be able to see my point-to-point links and the loopback interfaces. Remember, IGP's job is to carry only 2 types of routes, the loopback and the point-to-point interfaces, and these are called infrastructure routes. So they will just carry them. Because I enabled the ISIS in the interfaces, I should now be able to see all the interface and loopback IPs of my SR domain routers in my table, in my routing table, right? Because they started talking to each other and sharing, you know, I know these routes, do you need them, and things like that. So they're sharing the routes. Now let's see whether I have those routes in the routing table. Directly I'm going to the routing table, but please look at the adjacency and neighbor discovery, things like that. I don't want to spend time with those things because we have very short time. So this is in Juniper, IPv6 table is called INET6, IPv4 is called INET, and then there is a .0 because the table version is there can be multiple IPv6 table in Juniper. Juniper's way of their defining table is like table and then table number. So in here with 0 means a normal regular IPv6 table. Okay, and if I go there, you see my neighbors' IPv6 addresses are there already. They're loopback addresses and their point-to-point addresses, because point-to-point is 127, loopback is 128, and if there is any local routes, is also there. So most of them you see I received from ISIS, right? Most of them I received from ISIS. One weakness in our lab is that you cannot scroll up. It's because it's the console. It's not really SSH from another terminal. It's like the console of the router. But anyway, okay. So detail, some of the snaps are here. Just please see. I'm not gonna cover this at the moment. It's just how you look at your whole topology based on ISIS config at the moment. I can see I have all the routes, so I don't need to go every single route and do that. So that's pretty much checking about, so let's see if I have missed anything. Nothing here, nothing here. It's just the output. Please look at those outputs and see whether you understand them or not. It's basically routing table. Your routing table. ISIS had all the routes coming. Yeah, all the routers doing the same verification in all the routers. Please go ahead and do that. This is like optional config. I don't need to do these optional configs like this part. Enable ECMP or load balancing. At the moment, I don't need that though. But if you want, feel free to configure. Let's go to the next task is SRv6 config, but we'll start with ISIS first because currently I'm running a regular ISIS. I don't have any SR capability in this IS. Now here is the theory we have done, that there is a local block and the node. These two together it's called locator. And I told you that this is variable. You can define any numbers. In our lab, we are using 32 bits for the block and 16-bit for the node. So it's basically 48 bits. And then function 16 and then rest of the bits are arguments. So I said that this number is variable, so you can select at the moment. Yes, so at the moment, we have this number of bits we have mentioned. These are the default Junos, but we will use these values. Now our plan, before configuring, we have to make a plan. So our plan is our prefix for segment routing we are taking from FC. Remember, FC00 is a unique local prefix in IPv6. So it's non-routable. And that prefix you can even use for your real deployment, which is recommended, non-routable prefixes. Routable within your SR domain, not routable outside. And out of that, the third segment, remember 32-bit, and then another 16-bit for node ID we want to use. 16-bit for node ID. So this 16-bit we are using like a node, like let's say I have router 1 to 5000. So I'll just use like each node will receive 148. Each node with 1/48. Okay. Now I have only 6 routers, so I just made this plan for us. And now we'll do this config here. I'll explain it first and then I'll configure. PER1. In my routing options, I'll enable source packet routing SRv6. That means I'll enable SRv6 in my router. And then locator is, like I said, locator. Every single router will get a /48 out of my /32. /32 is my full domain's range. And then from there, first 32-bit is okay, but next 16-bit is the router number. So my first router will get 0001 along with my prefix that I decided. So it's a /48 as my locator. In Juniper, you name it with a given name. And then once you do it, you just apply it later. In this configuration, we are not applying, but we'll apply later. But that's just configuring the locator in my router. So let's go to router R1. Router R1. Configure this locator information there. And remember, somebody, I think you asked me like, this is why you have to configure this, like manually. So router R2 now. Just changes here. The number you see now become 2. So I'll do this config for router 2. So the plan comes first before configuring. So we have to plan it really properly, and then we'll configure in our routers. So this is coming from my plan. R4. You see, all the routers needs to have the locator information. Doesn't matter whether a P router or a PE router, as long as they are in the domain, they have to configure it. But their process will not be stateful, means they will not remember unless they need it. So this is R5 done, now this R6. Okay, done. Because I configured my locator, I have to apply it, okay, in my ISIS. So now I'm doing protocol ISIS. I'm enabling SRv6, and then I'll go and apply this locator in the SRv6. You see the locator I already configured, and now I'm just calling the name and should call it in ISIS. So that is the use of IGP extension. So now ISIS is SRv6 aware that ISIS functionality has been added. So go to R1 one more time, do this config for ISIS, go to R2, do this config for ISIS, go to R3, do this config. Now, because I'm enabling SRv6 in ISIS, each of the routers ISIS updates will also update the locator information as well. So locator information propagating with the help of IGP. No new protocol necessary for that. R5. This is R6. So, okay, now I enable individual locators in individual routers, and they are going to propagate the information with the additional TLVs. These additional TLVs are the extension of IGP. Now, one thing is, in Juniper, the regular routes or the default routing table is called inet.0 or inet 6.0, but the SR enabled routes for ISIS is called inet.3 or inet 6.3. So this is a different table where it keeps it. So now, if we see the verification, let's say do a verification whether so Spring is source packet routing for internet or something like this. So Spring is the work group in IETF that defines the SRv6 and SRs, things like that. So let's see one of the functionality, whether it's added to the ISIS. This Spring is enabled, means source packet routing is enabled, means segment routing is enabled in ISIS, okay? Now, if I look at my seeds, if you click on this link, it's basically saying, give me the seeds you have. So you see in each of my ISIS neighbors, it is giving me these prefixes along with my loopback IP. What ISIS usually gives me is the loopback IP and the point-to-point IP. Along with the loopback, now it's giving me the FCBB03/48. So ISIS is bringing the locators to the neighbors. You got the point? Previously, only the loopback and point-to-point and things like that. But now it's giving me the locator information. This is router 3. Router 3 is my neighbor. It's giving loopback and also the locator information. Okay. Now, this information, since available, all the 5, 4, 3, 2, and this is 1, and I'm in router. Which router I am in? I'm in 6. So if you see, this is mine, and I have my own, and this is like 0, right? And then if I see one of the routes, let's say this is my prefix, main prefix /32, from where all my locators has been added. If I see that from the prefix, if I look at the routes, this is inet 6.0, which means I have the global IPv6 table, and only you see the /48s, each and every /48, but they are, as you can see, they are collected by ISIS. But look at this 6.3, because 6.3 is the table that's coming by SRv6 ISIS. So SR is carrying the route, and Juniper router is putting the routes in both the INET table and also INET 6 table and INET 6.3. Why we are not looking at 4? Because we don't have 4 in our backbone. We only run IPv6 in this lab. That means we will have. And now interesting also is, you see, this locator is reachable via the SRv6 tunnel, and destination is the router itself. The router does not have /48. This is like the router itself. That's why double colon and then means all the bits are 0. No, not service. It's not a service. It's the node itself. The node itself is exactly what you have for the node. No service, because service will be added in the function field. I don't have yet the function field, so it's just double colon and means all the bits are 0. Okay, at the moment you see the number 5 is 5, not 5 colon D colon some, nothing yet. Okay, now let's go all the verification and checking for individual routers. I'm not doing the verification at the moment. Now here R6, I'm on R6 and it's saying, can you try to ping router 1? This is router 1's loopback. Okay, this is router 1's loopback IP DB8 colon colon. It's not even it's the public IP. Remember DB8. Our SR prefix is this one. So it's saying, can you ping this IP? Let's see. Yes, I can ping because it's in my routing table already. I will definitely be able to ping. How about the SR prefix? The SR prefix for router 1 is this. How about this one? If you click, it's failed. Why it is failed? Because it doesn't know what to do with this prefix. The packet goes to the router, but the router doesn't know how to go there. Okay. Now, how can we make it successful? We have to have a service now. So here, the command is this command. In the ISIS, I have to mention that I want one more parameter that's called end seed. End seed is the node itself. The node itself has a value. Currently, the node itself has a locator, not the value. So it does not know how, once the packet is there, what to do. Do I gonna do a decapsulate and then look for routing table? Or I'm just gonna do a pop? Or I'm gonna do service to find out whether this is a VPN or not, things like that. I'm not aware. My router is not aware. Even though the packet is to the router itself, it does not know that remove the header and look at the payload. It does not know that yet. So I have to configure the end seed, and end seed is the node's own seed, which is a 128-bit field. And that's also, again, you have to manually configure. So here, previously, up to this point, we have configured, but we didn't configure end seed yet. Now I'm saying my end seed is, I'm router 1. This is my locator up to 1. And then the next field is function. Remember, next field was function. The function is, I'm saying, my function is myself. To look if somebody ping me, remove the header and do a check by the routing table and find yourself there, something like this. So I'm basically saying, this is me. I'm a node and this is my ID. I'm basically saying that. So let's go to P1 and enable this, and we have to do it for all other routers as well. And then PE2, I don't think I have much time. I think we are already in the lunch period. But what I'll do is I'll explain very fast and quick, not configuring this, but I'll explain. So once we do that, if I do it in all the routers, what will happen is, now if you ping, you will be successful, because now the node knows that's me. If packet comes to that IP, oh, it's my IP, things like that. So it's not really same as the routing behavior. It's not the same as the routing behavior. Routing behavior means router knows it's me. It's my local IP. But here it does not know. You have to tell them. Now comes the BGP. BGP means if you want to do L3 VPN, you have to do point to point, you have to do targeted multi-protocol BGP, not with everybody. ISIS you have to do all with all your neighbors, but BGP you don't need to do. In BGP, if I want to send a L3 VPN packet to one other PE routers, I just have a multi-protocol BGP between these two routers, not the intermediary routers. So in here, we are configuring only with the R1, R2, R5, and R6, not R3 and R4 because they are in the middle. So we don't configure them. Configure the BGP. So here R1 will configure 3 peers. All of these are to activate SRv6 capability of the BGP, but I want to focus here. I have a peering with P2, P5, and P6, not R3 and R4. So this is like a L3 VPN configuration. The next configuration is accept routes. Only when you do BGP, you configure in filter and out filter. Only accept their routes and only give them whatever route you want to give. So this is like the filtering configuration. It's not related to SRv6, but normal BGP filtering. But of course, you allow their loopback, their loopback or this prefix, and also the SRv6 locator prefixes. Same thing for R2, but you see no configuration for R3. Yeah, no configuration for R3, R5, and then R6. So all of them have now a full mesh edge peering. And then let me go quickly in the bottom. Yeah, then the verification. I don't think there is more. So this is the L3 VPN configuration. And if we go to this task, this is basically how you finally go there. So all of this has the VRF name, VRF router, VRF RD, RT, and the locator information. So here, very quickly, for the VRF, I give a name, let's say R1 VRFA, and I put a router target and router distributor, RD, RTR concept coming from the MPLS again. And then once I configure it, the filtering configuration for the provider side is also there. This is the BGP peering with CE routers. And then similar thing for R5, because I only have customer CE on R1 and R5, no other routers needed. So R5 similar configuration, VRF, normal VRF configuration when you configure VRF with a customer. And then this BGP configuration is done. CE router will do normal BGP, no SR, no VRF, anything. It's just a global configuration because CE is not aware about VRF. And then normally a CE configuration is a normal BGP configuration, no VRF there. And this is the second CE. You configure the BGP there. And then do the ping configuration. Should be able to do ping, all the tests in each of the routers, same test for all the routers. Once this is done, we'll do a test in this part. Yes, here is the test of doing whether I can do a traffic engineering. That means my SR list remaining SR left and things like that. So in this list, I'm saying from R1 to R5, take via 2, 4, 3, 6, this path. And in this path, I'm saying hop 1, hop on is the seed for 2, hop 2 is 4, then 3, then 6, then 5. Now we can say this is manually created. If you have a controller, the controller will instruct. But here, because we don't have a controller, we have to manually do that. So once I do that, this path has been added to the configuration. This path has been added to the configuration. Finally, this policy has been added. Same thing for R5, the return path. No configuration needed in the middle because the source will decide which path to go. And when you see this, yeah. So when you see this, each of the segments has their individual list, and this is the list created for the header. Same thing for the other side. And if you see the route, the seed changed. You see the seed? Previously we said like 5, but this time we say 514 D4 colon. So the services is defined and configured by the router and it's locally significant, not globally significant. So please take a look at this and individual output, please analyze, and it explains why we need it and how come it happened. And if you cannot do the lab in one sitting, you can save it. For example, I can save the lab and do later by going here and save. It will save the lab for 7 days. Within 7 days, if you relaunch, it will exactly start from this time. And every lab has some time fixed. You need to finish that within that time. But if you can, there will be a warning. Do you want some more time of 30 minutes or something like this? It will be one time choice. You click and then the time will increase, but not anymore. So there is enough time actually. When we build the lab, we know how much time somebody will need, and then we add even more time and make it here available. So it should be enough for people to finish. But please share it with your colleagues as well. And if you like these labs, you can even try the other labs. It's all free, no cost needed. So yeah, I hope you guys got some good information. I'm sorry that I took more time, but I hope you got some idea about this. Okay, so I have some quiz and stuff, but I'm not gonna run it because we are running like that. Okay, so you have been very patient. Thank you so much for that. All the materials are free to share. It's a Creative Commons. Anything APNIC does is mostly free, so please accept the IP. IP is not. So yeah, please share with your colleagues. Thank you so much, everybody, and thanks to you as well for support. Thank you so much, and the staff who run this. Yeah, thank you. Thank you. Bye.